Hey guys, Miss C here. Today we will be starting our unit on quadratics. And so we just, before the break, started or learned about linear functions. And so now we are going to be talking about quadratic functions. So instead of a degree of 1, where linear functions we had y equals x, right? Or we had y equals mx plus b. Now we are dealing with functions that have an exponent of 2. And so instead of an exponent of 1, we have an exponent of 2. So in class, we looked at Desmos and talked about how these different transformations affected the parent function here. And you can see this over here. This is called the parent graph of a quadratic. And so this is the graph y equals x squared, where the vertex, which is the point in the graph where it turns, or where the bottom or top of the parabola is, and so the parent function or the parent graph is at 0, 0. So we're going to talk about what happens when we try to move the graph, either up, down, left, right, make it wider, make it skinnier, and how we can find those transformations just by looking at the equation. Okay, so we have a here, and some things to know is that whenever you are multiplying something, it's going to affect the graph either by reflecting it or by stretching it or shrinking it. And so a is being multiplied here, and so a, if it's negative, it's going to reflect over the x-axis. If a is bigger than 1, it's going to stretch it. And if it's smaller than 1, but between 0 and 1, because if it's less than 0, then it's negative. If it's a fraction, it's going to shrink. Okay? The next transformation we're going to look at is h here. And so h either moves the graph left or right. So whenever you see addition or subtraction in transformation, that tells you that you're either moving up, down, left, or right. And so since h is paired with our x value, which is our horizontal component, right, then that's going to move it left or right. Now, an important thing about h is it moves in the opposite direction than what you think. So you can see here that this says minus h, right? Minus h tells me, okay, if you had plus h here, like what this is saying right here, if I had x plus 4 squared, oops, that is going to move my graph to the left. And again, if you saw the Desmos activity in class, I got to show you guys what this looked like, but it's going to move to the left. And so your new vertex is moving to the left 4. And if I'm moving to the right, it's going to look like, x minus 3 squared would be to the right 3. Okay, so x always moves in the opposite direction than what you think it's doing. And that's shown by having this minus h here, okay? Cool, and then k is the last one we're going to look at. And k is moving up or down, and this moves exactly how you think it does. If it's plus k, it moves up. If it's minus k, it moves down. And so let's look at some examples and talk about the transformations happening here. And so here I see we don't have an a that is if you don't see an a there, then a is just 1, right? So a is 1, and there's no transformation applied there, okay? But the next transformation that I see is I see something with my x right here. So I see this minus 3, and this minus 3 tells me it's moving to the right. Remember, it's moving the opposite direction than what you think it is. So we are moving to the right 3. And then this plus 5 here tells me I am moving up 5. Okay? So that a equals 1 isn't really important for writing what your transformations are, but that's The only transformations here are because we have h and k values. And I didn't mention this earlier, guys, but what these transformations really tell you is where the new vertex is. So this is called vertex form because the vertex of a parabola, that's what having a quadratic written in this form shows us. We have our vertex is at h comma k, and so these values right here tell me what my new vertex is. And so if it moves right 3 and up 5, then my new vertex is 3 comma 5. But we'll get to that a little later in the notes. Okay, the next one, transformation. So I do see something going out front here. I see a negative sign, and so that tells me that we have a reflection across the x-axis. Whenever you see a negative, that means you are reflecting across the x-axis. So then the next thing I'm looking at is my h value, and so remember it's the opposite of what you think. So since it's -2, we are going to the right 2. And then for my k value here, we are moving up 7. Okay? Try 3 and 4 on your own, and you can just pause the video and try that and come back. And so this time we have a number outside of A, or as A, and so this tells me that we have a shrink, or better yet, we're going to call this a vertical shrink. A vertical shrink of 1/3. Okay? And then, when we're going to look at our h value next. So we have +3, we're moving in the opposite direction. So we're going left 3 this time. And we are moving down 2. The transformations here on this one, this number is bigger than 1, and so that tells me that we have a vertical stretch of 4. This -3 tells me I'm moving to the right 3. And this +8 tells me we are moving up 8. Okay, so that's how you determine the transformations, just by looking at an equation here. So now we're going to take this general form of vertex form, a times x minus h squared plus k, and we are going to identify those looking at a graph and then writing, the equation here, okay? And so I mentioned earlier that we have a vertex at h comma k, and so that's going to be really helpful when looking at a graph. And then this axis of symmetry, guys, this axis of symmetry is where x equals h. It's always written as x equals right here, and it's just a vertical line through the vertex. That's something that you'll see sometimes on a graph, and it's something that will come into play much more later on in this unit. And so first thing we want to do is find our vertex. And so our vertex is at -2, 1. And so that means my h value, so this is my x value, is -2. My k value is 1. Okay, and then finding what a is. And so to find a, so to find a, what you want to do is you want to start at your vertex and move to the right. It's basically you're trying to find slope in a way. So you want to go to the next point that you can see on the graph, and I see the next point being right here. And so I moved down 1, right 1. So since I moved down 1, right 1, my a is -1. Think down 1, right 1. How would you write that? As a slope that we learned with linear functions, okay? And you always want to go to the right with these. Always go to the right. And that makes sense that it's -1 because this parabola is flipped, right? It's upside down. And so that makes sense that our a is negative here. So now we're going to write our function. And so I'm going to just write our general form off to the side here. And so we have f of x equals a times x minus h squared plus k. And so that's what I'm using to write my equation. I have everything I need. And so I'm going to write this -1 out front here. And then I have x minus my -2. So this is where you can see that the sign changes when you have subtraction. And so we're going to simplify this in a second, but that's why it goes in the opposite direction here. So x minus -2 squared plus 1. So I'm just going to rewrite this as f of x equals negative x plus 2 squared plus 1. And you can check it if you want by looking at the transformations and seeing if they match your values at the top there. But that is how you write an equation when you're given the graph. Okay, let's try another one together. So the first thing I want to do is find my vertex. So my vertex is right here at, let's see, this is at 4, -4. And so my h value is the x value, and so we are at 4. My k value is my y value at the vertex. And so now we need to find a. So I'm starting at the vertex, and I'm trying to move to the right to the next point that intersects on the graph. And so where it intersects, well, is up 1 to the right 1, right? Up to the right. And so up 1 to the right 1, we just know that as a slope of 1. Okay, you only want to go to the first pretty point on the graph, and we'll look at some other examples in a second that maybe get a little bit more complicated. And so now we're just plugging these in. And so try it on your own for a second. Look back at the top of the notes for the general form. And it would be a is 1, so I'll write it right here as 1. And then we have x minus 4 squared, don't forget that squared, minus 4. And so this can just be simplified as f of x equals x minus 4 squared minus 4. Okay, let's try 7 and 8 together. If you want to take a stab at your own, go ahead and pause. First thing we are doing is finding the vertex, and so our vertex is right here at -5, -3, right here. And something that I haven't been mentioning with the previous ones is the axis of symmetry goes right down the middle of the parabola. And so you would write this line as x equals -5 because that's the h value right here. Okay? And so let's first start off with our h and k. So h is -5, k is -3, and now let's find our a value. And so we're facing up, and so it's going to be a positive value. And so we're starting at our vertex, and our next pretty point is right there. And so we're going up 1 to the right 1, and so that means that my a value is 1 right here. Try to write this equation on your own. You will end up with x plus 5 squared minus 3. Remember, opposite. Whatever you have as h, what you end up with inside your parentheses with x is going to be the opposite sign. Okay, let's look at number 8. Okay, so vertex. First thing, we are at -3, 2. And so my h value is -3. My k value is 2. Now let's find a. So here I see my next pretty point is it crosses the x-axis right here. So I want to go to the right and down that way. So I'm going to go down 2 to the right 1. Okay, so I went down 2 to the right 1. So that's going to give me, if I have down 2, right 1, that's going to give me an a value of -2. Okay, and we knew it was going to be negative because the parabola is flipped upside down. And so this parabola would be written as negative 2x plus 3 squared plus 2. Okay? Awesome, guys. Okay, so now we are going to go the other way. We are going to graph when we are given a equation here. So, and we're going to use our calculators for this. So if you haven't already gotten yours out, I would go ahead and do that. So the first thing we're going to do is find the vertex and then plot it. And then we're going to find the axis of symmetry, which is what I was telling you guys about earlier. So first thing we want to do is find the vertex. And we know that our vertex is h comma k. And so I'm going to find my h and my k right here. And my vertex is going to be negative 2, 1. Remember, opposite for your x, and then your y stays the same. So our vertex is negative 2, 1. So my graph is starting at this point right here. Okay, and then I'm going to go ahead and draw my axis of symmetry. So around this line, my quadratic should look symmetrical on both sides of this line right here. And so I'm going to go ahead and pull out my calculator, and let's see if I can do this with the iPad. All right, so here's our calculator here. So the first thing that we are going to do once you have your calculator is you're going to go to table, and then you're going to go down and click edit function, and you're going to type in the equation here. This is the equation that we have, and so if you wanted to redo this, you would use parentheses, use your X button right here, plus 2, close parenthesis. Your squared button is the button underneath that blue square root sign, and then plus 1. Okay, and so then I'm going to hit enter, and then I'm going to start at my h value. So our h value is, remember, our x value of our vertex, and so that would be at negative 2. Make sure to use this negative sign here. This is a negative sign, this is a subtraction sign. So be careful, you will get an error message if you use this sign instead. So then you're going to just hit enter until you get to the calc button. So I just hit enter 3 times. Hit calc, and then what this is right here, this is your vertex. And then this gives you 2 points, and then this table gives you all the points of the quadratic. So what we want to do to graph our quadratic is we want to find 2 points on one side and 2 points on the other. And so this is my vertex, this is my middle, and so I want to choose my 2 points on both sides. So I am going to go back to my notes, and I'm going to look at my calculator. And so from my vertex, I have, let's see, I have negative 3, 2 as one of my points, negative 4, 5 as one of my other points, and then I'm going to scroll down to the other side, and I have negative 1, 2, and 0, 5. And then last thing I'm going to do is connect my dots to make a U shape. And that is it. So that table function on your calculator is extremely helpful for graphing these functions. And so go back and watch that calculator walkthrough. I'll do it again for this one in just a second. So number 10, here we go. So first thing we're going to do is find our vertex. So we are finding our h value and our k value right here. So our vertex is at 4, negative 1. Remember, we are the opposite sign of what you see in here. Okay, so 4, negative 1 is our vertex, and so I'm going to plot that at 4, negative 1 down there. This is my axis of symmetry, and so whenever I graph both sides of my line here, or my quadratic, it should look the same on both sides. So let's go back to the calculator and go right here, and we will go, I'm just going to quit and go back to table, edit function, oh no, I cannot remember what it was. I think it was 2 times x minus, remember to use the subtraction sign here, 4 squared, and then it was minus 1. Let me double check that really quick. X, yep, there we go. Okay, back to the camera. So here's our function, so I'm just going to hit enter. And then I want to start at my h value. So my h value is at 4, remember? And then I'm stepping, don't change anything else. You're just going to go scroll down and hit calc. And then there's your table. So this is your vertex. And then you want to pick 2 points on one side and 2 points on the other. So I'm going to go back to the notes here. And our points here, let's see, we have 3, 1, and 2, 7 as 1 point, or as 2 points on that side. I'm going to scroll down and find my other points at 5, 1, and 6, 7. And then I'm going to connect everything together. And there you go. Okay, try number 11 on your own, using your calculator. See if you can do it by yourself, and you can check yourself with me. So go ahead and pause. All right, so our vertex here is 1, 2. So we are starting at 1, 2. As my vertex, my axis of symmetry goes right down the middle at my vertex. And so you're going to go ahead and use your calculator. I'm not going to show it for this time. I think you guys can go back and look and see how you plug this into your calculator. But what you end up with here is a point here and here. And then here, oops. 1, 2, 3, here. Here and here. Okay? And then connect these points. Maybe yours looks better than mine. But that is what your quadratic should look like. And that makes sense because there's this negative out front. So it makes sense that our quadratic is upside down. So guys, that is the notes for today. Hope this was helpful, having a tutorial for the calculator and the video and everything. So if you need any help, please feel free to reach out.